All right, you guys can hear me? Awesome. So thank you for the very nice introduction, and thank you for having me here. So I'm Yuriy. I'm going to be talking to you today about software fairness and how do you test software for discrimination. There's an echo. In fact, I'll start just by talking about what does it mean for software to discriminate. Now, the work I'm describing today is not just my own. There's some PhD students, Rico Engel and Sanyam are both PhD students, and Brittany Johnson's a postdoc working with us, and then Alexandra Meliu and I are faculty who are working on this problem. So let's talk about what does it mean for software to discriminate. So we all know in this room that software does important things, right? Banks are starting to use software to decide who gets a loan, who gets access to financial instruments. Rather than a human making a decision, a computer does. As was just pointed out with Lee, hospitals use software more and more to automate figuring out what's wrong with the patient, to automate figuring out a plan for how to treat a patient, and now even for treating a patient. And in America, there's this ongoing thing where before judges make a ruling as to whether somebody should have bail or how long someone should spend in jail, they get to see a computer-computed score of how likely is this person to repeat as a criminal. So there's 12 states in America that currently mandate using this kind of score. So software is making really important decisions, more important than ever before. At the same time, as I'm sure everyone in this room knows, software doesn't always do the right thing. So in 2013, Orbitz was steering Mac users towards pricier hotels than PC users. Well, not a huge deal. You might think it's a little unfair, but it gets worse. So 2016, just last year, Amazon used software to decide where it's going to do same-day delivery service. And it turned out that the software used lots of data, learned some things, decided this is going to make the most sense, while it decided to make racist decisions. It decided that we should not have same-day delivery to predominantly black neighborhoods, but to surrounding more affluent neighborhoods will have same-day delivery. Right? And it's interesting thing about this is that the software didn't even have access to race. It just had access to zip codes, but zip codes in America tend to correlate with race, and there was other data, so the predominant thing that it looked at is how many Amazon Prime users there are in a neighborhood. But the end result was that there was lots of publicity that Amazon made racist decisions on where to offer same-day delivery. So this is an example of software discriminating. We'll talk quite a bit about this example because depending on how you look at it, you could argue that it did or did not discriminate. But let me get back to that court thing that I was just telling you about. So that exact software that I told you courts get to see, judges get to see before making decisions about criminals' lives, turns out, of course, that software discriminates too. Why wouldn't it? So in particular, this is kind of tricky to say what does it mean for the software to discriminate. Well, so this software takes a person's criminal record, and it tries to predict how likely are they to be a criminal again. And so it's trying to predict something. And so if it's trying to predict something, it's going to make mistakes. And so with enough time passing, they're able to look back and see how often did it make mistakes. Well, of course, it made mistakes, and that's expected, but it turns out that with white criminals, it typically made mistakes that said that this person will not repeat as a criminal, and they did. Whereas with black defendants, it typically said this person will repeat as a criminal, and then that person did not. So it made mistakes, and there was bias in the way it was making these mistakes. So software can make mistakes, and software can discriminate. So this is a serious problem, and maybe you're all sitting over there and you're saying, well, look, I'm fairly well off. I'm unlikely to go to jail. In fact, looking at this audience, I don't see anyone that fit the profile that you just described of people who were adversely affected by that software. I'm probably going to get a loan if I apply for it. So let me give you some real-life examples that you guys use every day where software discriminates. How many people here have used Google Translate to translate something? Okay, pretty much everyone raised their hand. Well, here's what happens if you take the following two sentences in English. He's a babysitter, she's a doctor, and you type them into Google, and you translate them into Turkish, a language that doesn't have gendered pronouns. So there's no he, there's no she. Then you take that text, you put it back into Turkish, you translate it into English. He's a babysitter becomes she's a babysitter. She's a doctor becomes he's a doctor. This is live right now. You can go and you can try this. As opposed to, there was another example, I'll come back to it later, where Google was displaying racist ads to people based on their race, and then that has been fixed. So this is something that you guys might use all the time. How many people here have watched a YouTube video? Some people didn't raise their hands, that's impressive. Yeah, so it turns out that if you upload a video to YouTube and you use their automatic captioning feature, so it'll write underneath what you're saying automatically, if you're a man, it'll have higher precision in automatically transcribing what you said than if you're a woman. Okay? Here's another example, as soon as my slides catch up to me. There's this app, fairly popular, called FaceApp. And a little while ago, they had so FaceApp, you upload a picture, and then you can apply filters to it. So they had a filter that makes you hot, the hot filter. And for black people, it would make them whiter. So it used data, right? It wasn't just whiter skin. It did things like change their nose to look more European and things like that. So the big outcry, what the company did here is they just renamed their filter. It's no longer called a hot filter, it's called something else, which is pretty unfortunate. But software discriminates just all over the place. And has anyone here used vision software before? Turns out vision software is notoriously bad. So in fact, I don't want to tell you about vision software. I want to have Joy tell you about how vision software works today. So she's going to be talking about not a state-of-the-art vision software system, but a state-of-the-practice system. It's an open source system that lots of software uses.
Hi, camera. I've got a face. Can you see my face? No glasses face? You can see her face. What about my face? Well, I've got a mask. Can you see my mask?
So there are many vision systems that simply don't see black people. They don't recognize the face, right? And then these systems are used in other systems. Microsoft Connect had a problem where it wasn't recognizing people of certain races. We've got autonomous vehicles on the way. What if those autonomous vehicles start not seeing pedestrians of certain races? So discrimination is making a serious problem. And in fact, this is the state of the practice of vision software. Here's how companies today are trying to use vision.
When a candidate takes a video interview, they're creating thousands of unique points of data. A candidate's verbal and nonverbal cues give us insight into their emotional engagement, thinking, and problem-solving style. Unlike a traditional interview, recorded video captures the full content of an interview for analysis, including context humans might miss when taking notes. Now you can use all of that interview data to make better talent decisions. HireVue delivers custom assessments by blending the power of artificial intelligence with the science of IO psychology in a single video interview. No more long and boring traditional assessments for candidates. Reduce unconscious bias and promote diversity. This combination of cutting-edge AI and validated science is the perfect partner for making data-driven talent decisions. For the best talent, faster. HireVue.
So my favorite part of this video is that they say that by doing this you can reduce, they say unconscious bias, they mean to say subconscious bias, and increase diversity, right? And in fact, I understand the thinking, and I should have prefaced this by saying that this company actually cares about fairness, and they've been talking to us about how to try to make sure that their software is fair. But the bottom line is, they're going to have a computer look at a video of a person interviewing, answering some questions, and then they're going to automatically extract things like, this person is going to be great under pressure, this person is going to be smart. Now, given that vision software that people have worked on for decades can't even see black people, you tell me that that's going to improve diversity in hiring if we use systems like that. So there's a gap between how we want to use software and the fundamental problems of discrimination within that software. Okay, so what am I going to talk to you about today? And I've done enough scaring of this is a serious problem. So the first thing that I'm going to talk about is, what does it mean for software to discriminate? Turns out that this is not an obvious question, that there's a bunch of different answers and they kind of contradict one another, and different situations require different definitions of fairness. And then the second thing I'm going to do is I'm going to come up with a definition it's not perfect, but it's going to be, I think, really cool, and it's going to capture something about fairness that I think most of us will agree is really a key part of fairness in software. And I'm going to tell you about how we operationalize this to take software and test it, automatically test it for whether the software is fair. Okay, so let's get started talking about what does it mean for software to be fair. So the first thing you might say is, okay, if we care about software to be fair, why don't we just go and design it to be fair, right? We should, at the time of requirements, we should consider that fairness is important or not having discrimination is important, and we should make that a requirement, and then we should think about making algorithms that are fair, right? Well, in fact, lots of people have done this, and I'm throwing up here just lots and lots of papers. These are mostly papers in machine learning, where they said machine learning takes a system, it takes a bunch of data, and then it learns how to make decisions like that data. For example, it'll look at a large number of loan applications that people have applied for loans, and it'll look at whether people repay these loans, and then it'll be able to then take a new application and tell you this person is likely to repay their loan, or this person is not likely to repay a loan, or I'll tell you whether to give this person a loan. So if there's bias in the data, therefore, this system might learn this bias and then make decisions that are biased. So this is a common cause of discrimination, not the only cause. I'll talk about some others in just a second. So there's lots of work out there for how do we take biased data and then use machine learning in a way that produces non-biased classifiers. And there's lots of things you can do. For example, a common thing to do with machine learning is to balance the data set in terms of, so let's say that you have 10,000 people's applications, and you're trying to decide whether to give them a loan. And let's say that only 3 of those people have ever been successfully paid back their loan. Well, the system will just learn, don't give anyone a loan, right, which is not meaningful. So a more meaningful way to learn would be to balance the data sets in terms of the number of people who got a loan and the number of people who didn't get a loan. Right? If you balance that, then the system is not going to learn just, oh, if I just give the same answer every time, then most of the time I'm going to be right. And so the same idea can be applied to fairness. If, let's say that there's 2 races in our world, green and purple, and if we take the same number of green people who have in the past paid back a loan and the number of purple people in the past have not paid back a loan, and then also balance the numbers who have not paid back loans, then the system will again, you'll hide this bias. So this is one attempt. There's lots of others. I'm not going to go into the details. The bottom line of all of these is that they don't work very well for 2 reasons. One is that the definition of fairness that this enforces, which I'll talk about in the next slide, is not the one that you and I would commonly think of as what does it mean for something to be fair, right? And it's not obvious at all. When I'll tell you the definition, you might say, yeah, this makes sense, and then I'll show you why that's not the case. The second reason is that what you end up doing is you end up over-constraining learning, and when you over-constrain learning, you'll find some other solution that fits your constraints, but I will show an example of a system where when you tell it, don't discriminate with respect to gender, well, it found a way to discriminate with respect to race much more than before, because it was constrained. It was constrained to do something different than what it was originally doing, and so it just found another solution that, that satisfied your criteria, but not another criteria that you probably wanted to satisfy. Okay, so, but the key point here, I sort of got off track here. The key point here is that saying that why don't we just design software to be fair is exactly the same as me saying, why don't you just design your software to not be buggy? Why do you do testing, and why do you do maintenance forever? Why don't you just design it to not be buggy? Discrimination can come from lots of sources. It can come from bugs. It can come from algorithmic bugs. It can come from data. It can come from unintended interactions between components. And so it's just not enough to design your software to be perfectly fair. First of all, it's hard. But even if it wasn't hard, or even if we could do it right, still there would be bugs, still there'd be discrimination. So what we really have to do is the same thing we do for software quality. We have to test software, we have to be able to think about requirements in terms of fairness and things like that, so that in the end we can validate software actually does what we want. All right. So I've already been using the loan program in this talk. Let me just define it slightly more formally so that I can introduce some examples of discrimination. Okay, so imagine that you have a computer program. It's a loan program. An input to this program is a loan application, which will show up any second now. No, really. Okay, well, maybe I didn't push it. Maybe I did. I'm stuck. Okay. Much better. There's a loan application. So loan application, just for simplicity of this talk, I'm going to say it consists of 4 things: your income, your savings, your age, and your race. Okay, that's all it is. And then the program decides whether your loan should be approved or denied, right? So very simple program. I'm just going to use this for illustrative purposes. And I'm going to say that this talk is not about policy. And in fact, it's okay. I'll leave some time for questions. We can talk about policy. But the reason I want to say this is that discrimination is a weird thing. So in fact, if I were to say to you, software should not discriminate, depending on how you interpret the word discrimination, that might be complete nonsense, right? If software so what does discrimination mean? It means it does different things on different inputs. If your software did the exact same thing on every single input, it'd be really boring software. Really easy to write, but it'd be really boring. So in fact, it should discriminate with respect to certain things. And we would probably all agree that for this loan program, it would be okay to discriminate with respect to savings, right? The amount of money you have saved should probably affect whether you get a loan or not. And we would probably all agree that it's not okay to discriminate with respect to race. But there's other things that aren't so cut and dry. So age, is it okay to discriminate with respect to age? Well, age tends to correlate with savings. Maybe, maybe not. What happened? Who went away? My presentation is just going off on its own. So anyway, the point, oh God, no. The point that I'm trying to make is that there's a lot of really interesting policy questions that we could talk about here, right? When is it okay to discriminate? When is it not okay to discriminate? And they're important questions. But the question that I want to answer today, or try to start to answer today, is let's say that you and I have decided that we want to write a piece of software that does not discriminate with respect to race. How can we test that that software does not, in fact, discriminate with respect to race, right? So I want to answer the question of, we already know what the policy is, how do we go and make sure that that policy actually works in software, right? Which is orthogonal to the question of, oh, but there's all these other policies that are reasonable, right? And in particular, with the Amazon example, so Amazon ended up discriminating with respect to race when they did the same-day delivery service. Did it make sense for them to do it? Well, you could argue it was a business decision. You could argue that the business decision didn't work out for them because they got a ton of negative publicity, and they actually had to reverse this decision and allow same-day delivery services, and there was actually laws passed in a couple of states that outlawed this, specifically for Amazon, which is kind of weird. I mean, you could also argue that there's no such thing as bad publicity and all this helped them, so it's a really complicated environment, but this talk is not about policy, despite me constantly talking about policy. Okay, let's talk about how can we actually get the software to not discriminate. So here's option number one. You might say, why don't we hide the data? This loan application, don't tell it age and race. Forget about age and race, don't have those be inputs, and therefore the system can't discriminate, right? Well, it turns out that's not right. So there was this paper in 2013 by LaTanya Sweeney, LaTanya is a traditionally African-American name. And what she found is that when she Googles for LaTanya Sweeney, she gets ads like this: LaTanya Sweeney, arrested. And in fact, if you Google for names that are traditionally African-American, you are much more likely to get this ad. This was true in 2013. Google has fixed this since. If you Google for traditionally white names, you are less likely to get such an ad. Now, LaTanya Sweeney was a professor. She did not have a criminal record, so this wasn't a correlation of that kind. And in fact, if you were to click on that link, you'd find out she had no criminal record. But imagine you're applying for a job, and your future employer, or potentially not employer, goes and searches for your name, and the first thing that pops up is LaTanya Sweeney, arrested. Come see her criminal record. That's not a good thing, right? So here, she wasn't typing in LaTanya Sweeney African-American, LaTanya Sweeney Black. She was just typing in her name, so that's analogous to taking age and race out, but turns out there's correlations between names and races, certainly between names and genders and things like that, and life will find a way, so machine learning found a way to exploit this correlation. So just hiding the data doesn't work. If you ask Netflix, they'll tell you, if I know the last 20 movies you've watched, I know everything about you, and I don't need to know your race and your address. I can figure it all out. Because of that, unfortunately, you can't just take out age and race. And this happened with Amazon as well, right? They didn't have race in the software. The software didn't look at the race, but it looked at zip code, and zip code correlated with the race. Okay, so hiding the data doesn't work. Let's talk about a way to measure, right? I'm finally getting to ways of measure fairness. So here's a definition. It's called group discrimination. And what it says is that if you have green people and purple people in your world, and 35% of green people get a loan, and 20% of purple people get a loan, then we say this system discriminates 15% of the time, right? 35 minus 20. Okay, and so for the system to be fair, the percentages have to be within some epsilon. So this is one possible definition of fairness. And this is a pretty popular definition that's been used until sort of we got to the scene. So there's a couple of problems with this. The first problem is actually, I think, less important than the second problem, but you don't get to see the problems because I'm stuck again. Oh, no, they're here. Okay, so the first problem is that if there's correlation between, let's say, race and or age and savings, right, as there typically is, or age and income, then you might end up giving people loans that are just based on their savings and income, but you'll end up seeing a discrepancy in the percentages of people of different age who get a loan. So then you can start arguing whether that's discrimination or not, but the point is that you might have a system that you could reasonably argue does not discriminate, where this score tells you it does discriminate. The bigger problem is actually the other side, which is that you can get a system that clearly discriminates. I'll show you an example, but this score says it doesn't. So here's how that can happen. So imagine that I'm a bank, and I've got my loan application, my loan program, and I have lots of applicants from Europe and lots of applicants from Asia. And my loan program decides to give loans to all the green people from Europe and none of the purple people from Europe, but it does the opposite in Asia. So it gives loans to all the purple people in Asia and no green people in Asia. Okay? So clearly it's discriminating. Just your location and race determine whether you get a loan. Well, let's take another leap and say that there's the same number of green and purple people in Asia and Europe. Your discrimination score would be 0, right? 50, if the all numbers are the same, 50% of purple people get a loan, 50% of green people get a loan. And so what's happening here is that you can discriminate over here and discriminate over here in opposite directions, and they just cancel each other out. And in fact, we found examples where software does exactly that. If you try to force a software, you tell it, you have a constraint, you must not discriminate. It'll find things like, oh, if I just flip all the decisions in Canada, it'll cancel out all the discrimination over here in America, and bam, we have a reasonable system that doesn't discriminate. It satisfies your constraint, right? The problem is that you don't tell machine learning, don't discriminate. You give it a constraint. You say, the percentage of people who get a loan here must equal the percentage of people who get a loan here. And then it finds some way to satisfy it. So because of this definition doesn't work, and there's actually a deeper problem than what I've said so far, because if you consider things like, does race correlate with whether the loan is approved? Or is there mutual information, which is another measure, a statistical measure between two variables? Is there mutual information in race and whether the loan is approved? They all suffer from the exact same problem. So that example I showed you with Europe and Asia, the correlation between race and whether the loan is approved could still be, there could be no correlation, right? And there being no correlation doesn't mean there's no discrimination, because that example had discrimination. So in fact, lots and lots of existing measures suffer from this problem. The software can hide discrimination and come out looking like it doesn't discriminate. So where am I going with this? Well, I'm going towards something that many of you have probably heard before, that correlation does not mean causation. And what we really care about is causation. I want to know whether your race causes the software to act in a different way. So when I say software is fair, what I mean is a sensitive input characteristic, something like your race, should not affect the behavior of the software, right? Now, measuring causation is typically really hard. People spend their entire careers trying to figure out how to measure causation in data. Turns out in software, we're actually really lucky. We can measure causality. And when I say causality, I'm talking about the Judea-Pearl, sort of fundamental definition of what I mean by causality. Okay, so how can we do that in software? Well, in software, we're really lucky. Here's what we can do. We can test a hypothesis. I can take Yuriy, and let's see, so I'm blue today. So we'll take blue Yuriy, and we'll run my loan application through the loan program. And we'll find out, do I get a loan or not? Let's say I get a loan. Then I can take my application, and I can just switch my race, right? So exactly the same application, the race is different. And I run it through the software again, and I get some output. If they agree, then I learned very little. I learned that flipping my race didn't make a difference. But if they disagree, then that's one data point of the software discriminating, right? Everything else was exactly the same, just my race differed, and the output was different. Now, this is a little bit simplistic. We'll get to that in a moment, because really there's correlations, right? Changing my race will affect more than just my race. It may affect my salary, it may affect where I live, et cetera, et cetera. But for a second, if we discover that there's examples in our software where everything is identical in the applications, and just the race is different, and the output is then different, then that's a problem. That's discrimination software. So that's something we can test for. And in fact, something really important from a software engineering perspective is that, this is getting a little bit dated now, but we don't need an oracle, right? One of the big challenges in automated software testing is that, well, it's really easy to generate lots and lots of inputs. You can generate all the inputs all day long. The hard part is that when you run the test on these generated inputs, how do you know what the right thing is, what the right output is? You need some sort of an oracle. And you can have a human tell you what the right thing is. That's expensive. It's not really automated testing anymore. You can have a really weak proxy. For example, you could say, my software doesn't crash. That's my specification. You could have some sort of a more formal written specification you can try to automate getting an oracle from. But here, we don't need an oracle. The fact that these two applications should give the same answer is the oracle. So this allows us to create a completely automated way to test for this kind of discrimination in software. Okay, so we built a tool. It's called Themis. Themis is the Greek goddess of fairness, so it seems appropriate. That allows you to test software for essentially this kind of discrimination. So you can ask it two kinds of things. You can ask it, how much does my software discriminate with respect to race, or with respect to something else, or multiple things? And it'll tell you. Or you can ask it, does my software discriminate with respect to anything more than a certain amount of the time? right? So you can sort of go on this fishing expedition of figuring out, does it discriminate with respect to anything? And if you do that with a loan application, it might come back and say, discriminate with respect to savings, we discriminate with respect to income, right? And you might be like, yeah, that's fine. And we discriminate with respect to race. And then you might be like, oh, that's not fine. So Themis in some ways is limited. Themis works on software with categorical inputs, so things like loan applications, where you can have an age or an income or a race. And we're working now on trying to expand it to more complex software, things like where a photograph is an input, or a video is an input, or speech is an input, right? So things like that higher view video that I showed you, where somebody comes in and records a video of them interviewing, and then software does some stuff. Well, how would you do this kind of causal testing? Oh, simple. You just take the video and you flip the race of the person in the video. That's trickier. So we've been working on doing written text, which actually turns out to be harder than pictures. I sort of showed you an example where you can almost flip the race of a picture. There's more work on that. But if I were to take a sentence that you said and I were to try to flip the gender of that sentence, that turns out to be a hard problem that we're working on, and that allows us to evaluate how people react differently or how systems react differently to speech. Okay, so all the software is open source. You can go see it. Pretty soon there'll be a video that explains how it works, but it's not done yet. Okay. So what does Themis actually measure? It measures 3 kinds of discrimination. So the first one is this causal thing that I've been talking about, right? That's the most important one. It'll find the fraction of inputs on which flipping I shouldn't say just one, flipping any number of the sensitive characteristics that you've identified as sensitive will change the output. So it computes that fraction. It also measures group discrimination. The main reason that it measures this group discrimination measure is that it's really common in prior work. So actually, originally, the reason we implemented it was because prior work has looked at this. And so to compare to prior work, we needed to do this. What we found since is that there's actually examples where causal discrimination doesn't do what you think it should do. The discrimination that it finds isn't what you want. And I'll explain to you in a minute. So the Amazon example, actually, causal will not work there. And so group can help. So we'll talk about that example in a minute. But there's one more thing that I want to talk about. It's apparent discrimination. So apparent discrimination is something that we stumbled upon in the middle of this work. And that is that you can actually build a system that discriminates, but it doesn't appear to. And that actually may be okay sometimes, and I'll show you an example. Or you can do the opposite. You can build a system that does not discriminate, but it appears to discriminate, like the Amazon example. The system actually is fair. Well, I'll explain why. But it certainly appeared to discriminate. And lots of people thought it discriminated, and so there was lots of media attention to it because it appeared to discriminate. So what do I mean by these apparent discrimination? Let me show you examples. Imagine that here's a world of all possible customers, and you have a system that discriminates on some of them. They'll show up any minute now. They showed up here. There they are. Okay. So let's say that you have some customers you discriminate against, but let's say that all of your customers are not in that batch, right? So how can this happen? Well, imagine that you're a European bank, and you used lots of data from past European applicants to figure out a model of what is a good applicant for a loan, an applicant who will pay back the loan. And then you use this on other applicants from Europe. And let's say that your training was really, really good, and your model is good, and it's accurate, and it's every single time it'll tell you the correct thing, and it doesn't discriminate. But then you come in, and you throw applications from American candidates, and American credit files are completely different, and the behavior is different, all kinds of things are different, and it ends up discriminating all over the place over there. Well, if you're a European bank who's not going to give any loans to people with American backgrounds, maybe that's fine. Right? And so even though that your software, it discriminates because it didn't get any data from America to train on, how can you expect it not to discriminate on those? But it does fine on your customers. So it is insufficient to just take the system and sort of test it on all possible inputs, because it'll discriminate on a bunch of irrelevant inputs. So we found that this is actually an important thing to do, and so the people must be able to specify the domain, the input domain for your customers, the operational profile for their customers. Okay, again, this is sort of the less important view. Here's the bigger problem. Imagine that you have software that doesn't discriminate at all, right? So on all the customers, it doesn't discriminate, but you have very particular customers. Your bank only has poor green customers and rich purple customers. And so then, when you apply this fair software to your customers, only purple people are going to get loans. And it's going to appear as if you're discriminating. This is what happened with Amazon. There was it looked at different neighborhoods, it decided which neighborhood, which zip code is going to get delivery. If you had taken one of these neighborhoods, one of these predominantly black neighborhoods that it decided it's not going to do delivery to, and you had created an exactly the same neighborhood where people had the same incomes and the same subscriptions to Amazon and all these other things, but were of different race, it also would have said, don't deliver there. But such a neighborhood does not exist, right? In the real world, you don't get to see all possible customers, you get to see a subset of the real of all possible customers. And so there, essentially what happened was you had exactly this case where you had Amazon's customers happen to be using Amazon in different ways based on race, and so the software made essentially a business decision of, oh, we're not going to make as much money if we have delivery over here. Nevertheless, this was bad for Amazon. And in fact, at the very least, you could argue that Amazon should have known about it before they made the decision to go public with this algorithm, because at least they would have sort of been ready for the fallout or something like that, right? They were surprised by it, so testing could have prevented them from being surprised by it. Okay, so what does this mean? What this really means is that it's not enough to just sort of take Yuriy and flip Yuriy from blue to green. You have to be able to specify what are the valid inputs, what is the valid subdomain or operational profile of inputs to your system, and then you should be able to test within that operational profile, and so Themis will let you do that. Okay, so how does Themis work? I didn't want to go down into very low-level details of how Themis works. Essentially, at a high level, if you were to take every possible input, right, every possible loan application and run through a system, then you could measure how often flipping one bit, flipping the race, or something like that, changes the output. But exhaustively testing software isn't feasible. So essentially, all of the technical work in this part is how do you actually make it generate tests that are reasonable and that give you some confidence. So there's two things we do. Let me start with sound pruning. We've proven, so given the definitions, both group and causal discrimination, you can prove that there are certain conditions under which once you've discovered a certain amount of discrimination, it can only increase. And so you can prune whole subtrees of your search space that will limit, well, the search space. It'll limit the number of tests you have to generate. I'll show you, so I don't want to go into more details of exactly how that works, but I'll show you some empirical results of how much pruning actually happens. The second thing that you do, and this is fairly standard, you do sampling when you do automatic test generation. You do sampling. You're not going to run every possible test. The question is, when do you stop? So with Themis, what you can do is, so you have to give Themis the input schema for your software and an executable of your software. It doesn't need source code. It's a black box testing tool. But then you also give it a confidence that you require in your answer and an error bound. So you might say something like, I'd like to know all of the things that my software discriminates at least 20% of the time or more. And when you give me the answer, I want there to be no more than 1% error bound around that 20%, and the confidence I want in that error bound is 95%. And so what Themis does is then it iteratively creates some tests, runs them, finds out how the software is doing, measures its confidence in that answer, measures the error bound around the answer, and then decides whether it needs to generate more tests or whether it's done. And so this allows it to sort of iteratively improve the test suite until it gets to the answer you want. Of course, the higher confidence and low error bound you want, the more tests it has to generate. Right? If you want 100% confidence, you're going to have to run every possible test. Okay, so let me tell you a little bit about what we actually used Themis to measure in the real world. So what we did is we went out and we got some software. So all of this is open source software. None of the software is, well, I shouldn't say that. As far as I know, none of the software is being used in companies, but it's open source software. 4 of these things are just machine learning, standard machine learning that are part of scikit-learn-kit that people may use. And so 4 of these systems have nothing to do with discrimination. There's naive Bayes, a decision tree, a logistic regression, and an SVM classifier. They take data, they build a classifier, and now you can apply the classifier. The other 4 actually come from those papers that I threw up on the screen a while ago. And these 4 try to make the systems not discriminate. Right? They focus on group discrimination because when they were done, causal discrimination was not a thing. And so there's one that is a logistic regression that tries to be aware of discrimination and reduce it, decision tree, a naive Bayes classifier, and another decision tree that tries to do some other things. So we took these 8 systems, and then we trained them on 2 data sets. So the first data set is the census income data set. So this is income data for 45,000 people. And then it tries to, the way people have usually used this data set in the past is that you try to predict whether someone's income is more or less than $50,000, right? And you have the ground truth there. You don't use that to learn, but you have the ground truth on whether somebody makes that much money, and so you can find out how well the system performs. The second data set is called the Statlog German credit data set. This is 1,000 German people, like you guys. It has their credit data and whether the person has good or bad credit as decided by some credit agency, some label, right? So, I mean, really, to some degree, none of this matters, right? We took some systems, we took some data, we trained them. The goal is to show not that, oh, look at this system discriminates. The goal is to show Themis, when there's discrimination, can actually find it. Right, that's the goal. But these are real systems and it's real data that we try to use and learn. So we created 20 what I call system instances here that we tested. So the reason there's 20 is that there's 4 systems on 2 data sets, that's 8. And then these discrimination-aware systems, you can tell them, don't discriminate on X. Right, so what we did is we told the systems don't discriminate on gender, and we told the systems don't discriminate on race. So for each one of those, there's 2 instances. There's the non-race discriminating version and the non-gender discriminating version. So for a total, we have 20 different systems. So then we evaluated them, and I want to just give you some highlights of what we found. So the first thing we found, and this is perhaps not surprising, is that group discrimination is not enough. So we found examples where group discrimination was almost 0, is 0.4 or something like that in this case. So this was a particular decision tree that was trained not to discriminate with respect to gender, and sure enough, it did that. It managed to learn a model that had a very low group discrimination against gender, but the causal discrimination was 11%. So what that means is that in this system, if you take a random input and you flip a bit, the gender bit for that input, there was an 11% chance that the answer would change. So it went from good credit to bad credit, or from bad credit to good credit, even though previous methods would have said there's no discrimination here. Okay, because the same number of men and women had good credit or bad credit. Okay, so group discrimination is not enough, and so what this says is that exactly that thing I told you about happens, where it finds a way to discriminate in one direction over here and the other direction over here. It cancels out, and you get a system that looks like it doesn't discriminate, but in reality, when you look at individuals, you are discriminating. So in fact, this difference can be really significant. So we saw examples where causal discrimination was 21 times higher than the group discrimination in the system. So it can really end up injecting a lot of discrimination in certain ways. Okay, another interesting thing we found is that trying to avoid group discrimination sometimes caused problems. So what do I mean by that? Well, we had an example where so this is the same decision tree. I'm kind of picking this one decision tree because it sort of did the worst of them all. But when we trained a decision tree not to discriminate against gender, it ended up discriminating against race 38% of the time. So like all the time, well, not all the time, but really, really often, right? And I actually don't have this on the slide, but I should say that without telling it not to discriminate against gender, it did not discriminate against race this much, right? So we over-constrained the system. We told it, don't discriminate against gender, and it said, okay, I'm constrained, I'm going to do something weird elsewhere, and it just happened to, it didn't try to prioritize that, but it just happened to do that. So the moral of the story here is that when you decide to build your system so it doesn't discriminate against some known knowns, you might accidentally end up injecting other kinds of discrimination. So it's really something that you have to think about up front. What are the different classes, and how do you do tests for them that are important to your system? I want to mention something about pruning. I didn't talk too much about pruning, but pruning was highly effective. So on average, pruning reduced test suites by 148 times, right? So something that takes half a year to run instead takes a day to run. And for causal, Right, so for causal, it reduced test suites by 148 times. For group, it was even more effective. Group is sort of in some ways easier to measure, so you can get almost 3,000 time improvement. And the best example we saw was 13,000 time improvement in reduction of test suite. There's actually an interesting thing, there's a theorem that we're able to prove that the more your system discriminates, the more effective pruning is. So, I mean, it kind of makes sense. The more your system discriminates, the easier it is to find discrimination. And the easier it is to find some discrimination, the more we can prune away so we don't have to search for more discrimination in other places. But essentially, Themis, I sort of left this off the slides, Themis is not super efficient. If you want to find discrimination, it takes time. You have to generate lots of inputs, and you have to run lots of inputs to try to find cases, especially in systems that discriminate a little bit, right? Because those cases are hard to find. Same as bugs, right? We will never be able to eliminate all bugs from software systems. Same thing is true with discrimination. The really weird cases, they're harder to find, and so you'll always find things like that. So there's some hope. Pruning is effective, but I really should say that we've barely scratched the surface in terms of efficiency of making these test suites smaller. There's so much more to do that you can do. We've been focusing on trying to expand to larger systems and some more complex inputs, but improving efficiency is also another important thing. So there's lots of related work, most of which I've actually talked about before, already, I should say. So there's different ways of measuring discrimination. We talked about those. There's some algorithms that try to proactively be discrimination aware. And so what I've shown is that they do a reasonable job in a very specific view that you make them. So if you tell it not to discriminate with respect to gender, it may do that. But then it will introduce discrimination either against race or this causal measure. There's no algorithms out there that try to prevent causal discrimination, at least yet. And I think there should be, and I think the work is starting up in that space. We talked about how to, we didn't talk about this, but there is some work on measuring discrimination with manually written tests. So there's a system called FAIR test. And so if you write a bunch of tests, it'll then go and it'll come back and tell you things like, here's the group discrimination score for those tests, and it'll tell you things like there's correlation between this and that. It doesn't do causal because, again, causal didn't exist when they did their work, but you could, given a test suite, do that. The only problem is that your test suite needs a particular property. Your test suite needs to have these causal pairs where just the race is flipped or something like that. If it doesn't have that, we can't tell you much. So manual testing can go part of the way, but this is the same as with all testing. And manual testing is important, but it's not as automated as automated testing. There's a lot of work that looks at executions of software and tries to infer a model of the behavior. And I've done some of this work, and other folks have done work where they look at lots of data and they try to infer causal models of what causes what. So this is in some ways more sophisticated. It usually deals with much harder scenarios than what we have. Here, honestly, in data inference, of causal inference in data, being able to infer causality is this holy grail. It's almost never achievable, and in some situations they can find it. And with software, we don't know how good we have it. We actually have the system that we can prod. We can change that race and we could see what happens. We can do causal experiments, and it's a really powerful tool. And finally, there's some work, so OOPSLA just happened, so finally this paper is presented, on trying to formally verify that your software has certain fairness properties. Again, they only looked at group discrimination, so people have not caught on yet to this important difference with causal discrimination, but still it's an important step forward. Okay, so I'd like to sort of stop here. I'll summarize again what I said, but I really want to open this up to questions because I think this is a really important problem, and it's an important problem that industry is starting to understand is an important problem, but I don't think that there's enough. And so I'd really like to hear from you guys as to what is it that, how can we help industry try to make progress into this problem? There are, I do not want to make it sound like industry is not working on this. I know that there's groups at Microsoft, there's groups at Google, I'm sure there's groups at other companies that are specifically dedicated to trying to ensure fairness in their systems. I would say that they haven't gotten very far yet, but neither have we. But anyway, what did I tell you about today? Well, I told you about a new definition of fairness in software, this causal discrimination definition, that I think really captures something very important about fairness in software. And it's not perfect. It doesn't capture all examples. In particular, with apparent discrimination, you can create weird data sets of customers where there do not exist these causal pairs. There do not exist duplicates of potential applicants that only differ in age or only differ in race. And so it's not perfect. There's cases we can come up with where it leaves you unable to measure discrimination, but in many cases it measures discrimination better than prior methods. I told you about Themis, which is this open source tool, which doesn't work on all software, but it works on software where the inputs are categorical, so it's something. I told you about some ways to try to make the test more efficient, and then I finally showed you, then taking real world systems, some of which were even designed not to discriminate, we were actually able to find that there's quite a bit of discrimination going on in those systems. So that's all I had to say, but I'd really like to start a discussion about what does industry think about fairness? Nothing? How many of you have actually, I want to be careful here. How many of you are willing to say that your company is doing something or is aware of the problem? I got one hand. Having heard this talk, how many of you think this is something that industry needs to think about? Right? More hands, good. At least 2 orders of magnitude more hands. Yeah, I mean, we just don't think about it. It's crazy. There's all these studies that show that people just don't think about certain kinds of biases that are going on around them, and then you tell them about it, and these are people who care. These are people who don't want bias, but you just don't think about it until you're told, and then they want to try to change something. So I think this is something industry needs to start thinking about. Was there a question? Yeah? Mm-hmm. It is give everybody a loan. Mhm. Mhm. Yeah, so the question essentially said that, look, it looks like you can't not discriminate, right? All the software discriminates, you can't get away from it. I don't know if that's necessarily true. I think certainly in some domains you can actually make software that doesn't discriminate, but I do agree with you that there's going to be examples where you can't get away from it. And perhaps maybe a more direct way to say it is that so when Amazon did their same-day delivery service, their system was trying to make a smart business decision, was trying to maximize profits. You could argue that if you add the extra constraint of trying to not discriminate, you may not be making an optimal business decision. I don't know if that's always true. Presumably, it's at least sometimes true. You know, there's all these examples. There's mutual funds that divest from, let's say, coal, and people say that, oh, but if you maybe coal was a bad example. That invest in green technologies. And people say, oh, if you add this extra constraint, you're gonna not have as high a rate of return, and then they end up with higher rates of return. So I don't know what happens if companies start caring about discrimination. You know, maybe somebody comes along and says, we made a translator that doesn't make she's a doctor into he's a doctor, and maybe people start using it, and maybe even though it makes them somehow in other ways not as optimal a translation, nevertheless, it gets customers and it makes more money. Did the Amazon example help them or hurt them? They got a lot of publicity. It was bad publicity. Nobody went to jail. They didn't have to pay a fine. I don't know. Maybe they made more money in the end. Maybe they made less money in the end. So it's a very complex infrastructure. As I said, this talk is not about policy because I'm not an expert in policy, but I do think it's an important problem. And you know, I should say that there are companies that also just care about being fair, right? So even if it affects their bottom line, maybe they think it's important. My job is to provide the tools so they can do that if they so care.
So any more questions? We also have some microphones. Martin, please.
Yeah.
Well, I think you never can't do better than humans can. So at the end of the day, when you make, as a human, you make business decisions, what you want to do is getting kind of an optimal business decision under certain constraints, including legal constraints, including also certain ethical constraints. And the real question is, which kinds of constraints do you include? That's what's defining fairness. Because when you're going for systems, you can't expect that a system will ever be better than this kind of, well-thought human decision-making. And so it boils down to the question, is a certain attribute which does have an influence from the risk, for example, is it ethical, is it legal to use it for discrimination? Take health insurance. Many countries, it is illegal to discriminate against gender. Although we know that there is, from a cost standpoint, women are more expensive than men.
We know that?
Well,
I thought it was the other way around, but okay.
You can get the statistics. In certain age ranges, women are more expensive than men. They live longer, and they have other risks. Mm-hmm. But it's illegal. Mm-hmm. So if you are deciding for health insurance, you have to give the same offers. You must not discriminate. On the other hand, when you sell voluntary health insurance for the hospital, where you get the prime treatment, it's perfectly legal that you don't give offers to people of my age. That's allowed. It's
30-year-olds can't get insurance?
Well, that you don't give offers to people over 64 or 70 or whatever. Or you give them offers to much higher prices. That's perfectly legal. That's not age bias. That's not unethical. So it is a kind of, what does the law consider to be, and what does a society consider to be ethical or non-ethical in terms of what could be used for discrimination, regardless of whether statistically it has an influence or not. So fairness at the end of the day is in the eye of the beholder being the society.
So absolutely, I agree with many of the things you said, although not one. So there is an important policy question. Someone has to decide what is okay and what's not okay. To some degree, let's say that the government comes along and says, okay, we already have laws that mandate that a system that predicts how likely someone is to repeat as a criminal is used in court systems. Well, we might say this system must not discriminate against race. To date, they have no way of checking whether the system discriminates against race. They don't even have a language of talking about what does it mean not to discriminate, right? They could say something like doesn't discriminate against race, and then good luck figuring out what that means. So we need tools like this that help you understand those kinds of questions. The one thing that you said that I disagree with is that you said that we can't possibly do any better than humans can. I don't know if that's true. There's a lot of subconscious biases that when you program into algorithms, it's possible you can actually bring them out. Right, and I should say another thing, which is that we can actually improve quite a bit what humans do. Right, there's all kinds of known biases in hiring, for example, and there's a whole slew of companies. One of them I showed you that video. We're working with another one that does blind interviews, where it's sort of like a Turing test. You write an answer based to a question. You get to evaluate these questions without the application, without the application, without knowing who said it. But there's still potentially subconscious biases where somebody writes a sentence that because a woman wrote it, it's said in a particular way, and even though it's not obvious, subconsciously we interpret that, and then subconsciously we have other associations. So it's a very complex space for sure, but I think we can improve both what humans do, and I think it's conceivable that computers will actually do better than humans with respect to fairness. Right? Or at the very least, if we think proactively about fairness, we may be able to design better processes that even humans too could follow, but algorithms can follow them as well.
One last question, perhaps. Yes, over here. Marcel.
Yes, maybe slightly off topic, but I do think about automatic driving cars that have to make some decisions. Mm-hmm. Maybe there was a situation where, let's say, one child on the right could be damaged by the car. That's only one person, or if the car continues driving forward, let's say the car would damage two other persons. Maybe the car have to think about the age, the child, and so on.
The health insurance.
Do you think that kind of testing framework could also help the developers of the algorithm in the automatic cars to make better decisions? That's my question.
Yeah, so that's a good question. I mean, look, this kind of work is not going to solve the age-old philosophical questions of do you switch the train track to kill one person instead of killing 5 people, or do you just stand by and watch? You know, these are hard questions. This kind of work, if you make a decision of what should happen in that case, it can tell you whether your system will do that, right? It's testing. But yeah, I think that there are. We just wrote a proposal with a company that's doing autonomous vehicles to try to figure out, is there, because they use vision systems quite a bit, so try to test their systems for that kind of bias and trying to see whether they see different people differently. Is there a lower percentage? Right? It's not going to be the case that, oh, I don't see black passersby, but I see white passersby. But there might be a slightly lower percentage, or if there's a group, I may miscount them or something like that, right? And so testing for those kinds of things can help you identify problems in software. And I think that there's certain questions within the realm that you described that you can answer, but software testing is not going to tell us whether it's better to kill one child versus 2 adults, right? I mean, that's, yeah.
Okay, Yuriy, thank you very much for your great presentation.